Hello viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're going to talk about budget lasers and its big innovation. So let's dive deep into it. Now first we have to understand some context and timeline. Basically the first time somebody put some theoretical concept behind it, that was in 1970. This gentleman, maybe you have heard of him, known as Albert Einstein, and that proposed the theory, the framework of how the heck atoms would behave, something like that. So that was in 1970. Now after that world went to boom, and then while things calmed down in 1950, the first maser was created. Basically this puppy, this was a microwave laser. Now let this be clear, this laser phenomenon, or basically what you see there, that can happen with everything in electromagnetic spectrum, be it radio waves, be it x-rays, be it gamma rays, be it ultraviolet, or whatever have you. Basically the whole electromagnetic spectrum, it can work with that. So this was the first time where this theoretical concept was proven in practical reality, that A, it's here, B, it's real. Now of course after that there was still some doubt that maybe it can only work with long wavelength or things of that, but that sort of changed, went out to the door in 1960. Theodore, basically this gentleman, once he figured out how to use a ruby rod to make a red laser pulse. Now be mindful, it was pulse, it was not turn on, it stays on, it was not like that, it was a pulse system. But it proved the concept that it can work in this wavelength, and that kind of turbocharged the research on that. So he had a xenon flash that went kaput, and that flushed enough light into basically everything, and that ruby rod started to laze. It had like back and forth, and ta-da! So it did work. And the moment that happened, everybody just like ran with it. So just parallelly, other people figured out how to do infrared laser, other people figured out how to do continuous wave laser, and by 1961 we figured out how to make ultraviolet laser. That was in 347.2 nanometer. That was classified as UAV zone. Now ultraviolet has a lot of zones, like you have deep UV that is used in Amstrad machine. So this was not very deep in ultraviolet, but more than good enough to be classified properly as ultraviolet. And by 1980s we finally reached fiber pumped lasers. This is the backbone of today's laser reality. So you have to understand this, like science was sorted out in 1970s. By 1980s, laser engineering was sorted out. We were working on economics after that. So economics part, basically the cost of this. This is a wondrous technology, flat out wondrous, meaning it affects everything. There is no world without laser. Like, to give you a simple concept, storage. Now, is that important? Yes. Computer industry would not have existed as it exists right now if this was not the benefit of optical disk, CDs. Now, like, why? Well, here's the deal. Floppy drives were big, but not that big. And hard drives started to come in, but they were not that big. So they were talking, and not to mention they were ludicrously expensive and idiotically fragile. So you had like 10 megabytes, 20 megabytes, and now you had like a scenario where if you want to ship an operating system, you can ship in multiple floppy disk or one CD. And CD, because it was designed for music industry, it was designed to be cloned, mass produced. So that created a scenario where softwares became a thing that you can A, make it into physical reality, B, sell it to other people, be it Adobe, be it Microsoft, be it everything that you can think of, generally has a legacy that starts like that, be it PlayStation 1. So that's how we started with that. Was like, what we call infrared laser. Then we evolved to red laser, that went into DVD, PlayStation 2. Then we went into blue laser, that went into Blu-ray in PlayStation 3. So you get the point. Like, world right now we can laugh it out as like, who cares? But here's the deal. If we did not have this early storage era, we would not have computers, we would not have a need for internet, because okay, what the hell you are doing? So like, you have to lay the foundation, like, build a road, then you drive Ferrari on top of it. So road was built by optical media. So storage was there. Medical science, there are so many things that use laser nowadays, it's hilarious. For example, from multiple eye surgeries to skin care to hair transplant to, I'm not joking, this happened to me. I had to have some sort of a gum implant and root canal treatment, capping stuff. They use laser. Not even joking. Smells bad, but it does work. No sound, it just stings bad. So medical science is like, nowadays laser and medical is like, duh. And then you have communication. Right now you might be like, okay, fiber. How the heck do you think fiber works? It has laser. LEDs were not good enough. So laser had to be utilized. Only then you can have enough collimation of energies in photon spectrum that you can just force it down the tube. So, and material science. Material just went YOLO through it, including fusion. So let that be very clear. It's a flat out what we classify as wondrous technology. It's not like hee hee ha ha or like, it has a minor impact. No, it is the impact. It's almost as same magnitudes as a transformer. So it's a very magnificent thing. And when it comes to material, what can you do with it? Well, you can do welding, duh, car chassis. You can do cutting, logical. You can do stripping. Basically, if you have a paint, you can strip it. You have rust, you can strip it. Or you have a PCB, you can strip whatever you want to strip out of it. And then you can even do drilling. And be mindful, if you've watched old, very old, I can't even recall exactly how old it is, like 2005 or 2010, that sort of time zone, there was a channel known as History TV or something like that. And they had a some factory. I remember this very precisely. They talked about they had lasers for cutting sheet metal, and it was 5mm. And they said like it was so amazing because they cut the sheet metal, stand it on its edge because it was burr free. But they said like this does not work on thick metals because again, that time a laser was not that powerful. Technology was there, science was there. It's just that we did not have figured out how to make large enough, cost effective enough. So we were like, okay, we know this, but 5mm, but you have to cut anything around 1-inch thick steel. They had to use plasma cutter, and they said like it can cut with thick metals, but you have to degrind it and all that. Like there was a lot of steps afterwards. This is nowadays modern laser. 1-inch thick steel is like, bro, don't worry about it. Don't you worry about it. I'm not joking. I have seen this. I may not be able to find the precise video because again it's in Chinese, but they were talking about certain types of large scale, like big fiber lasers. Those were so heavy duty, they were used for naval assets. Naval ship, like multiple inch thick steel, and the power rating was something stupid like 60 kilowatt or something. And they required like pressurized nitrogen or oxygen. So to get the point, like right now, you have reached a point where laser can just deal with it. It's just, you most likely don't need to use plasma for things, so to say. So flat out, you can do a lot of things with material and lasers. And the only two knobs that you get to control is basically power and wavelength. Power is basically how much oomph you have, how many photons you have. Wavelength is basically what is the singing frequency of that photon itself. Now, why does that matter? Here's the things behave differently. For example, you would think like steel, it's a higher melting temperature and like, it's harder, it's tougher, so it may require more laser power versus aluminum alloys. Answer is sometimes invert. Why? Many aluminum alloy was surprisingly good at reflecting the heat away because of that exact wavelength that we use for laser. So that wavelength resonates with it, is like heat out of it. And not to mention it's a very much better conductor, so heat gets wicked away much quickly, so it becomes difficult. You have to brute force it, as in use far more power. So let's just say you are using 5 kilowatt to go through steel, you might need to amp it up to 8 kilowatt to go through aluminum. So that's why you get two knobs, not the power alone, power and wavelength basically was the singing frequency. And right now, drone industry had made it very like short uptake money for laser system. Now be mindful, lasers, people always wanted to do laser systems from Star Wars, and not to mention America was smoking something good, and they were like, what if we had a nuke? What if it goes kaboom? What if it creates enough gamma rays that lasers down into X-rays, and that X-rays can be aimed? And what if we boom hundreds of ICBM in one go? They were smoking something good. So again, we have been trying that, and not to mention they actually built a airborne high intensity laser ICBM boomer, but it did not work that well. And be mindful, this is very early on, so they were using chemical laser, but technology kind of proven its certain philosophy of it, as in like, yeah, you can have something like, yes, atmosphere will annoy you, yes, you have to deal with this and this, let's say, but like proof of concept was like, damn, you almost made something that worked. So that was there. And right now, because we have cheap drones, there are only two ways of dealing with cheap drones. You go back to World War II and bring back basically anti-aircraft gun. Those things are cheap enough, robust enough, and were designed to handle swarms from day one. That was the whole thing. And that's why like Germany's Gepard system, if I'm not mistaken, that's like, Leopard tank with an anti-aircraft gun on top of it. It's killing it in basically Ukraine. I think I saw one tank that had like 5-6 Shahid drone as a kill mark. So either you do that, problem with that is like people have forgotten like how to make those things, and the whole supply chain is gone. And it does have a penalty that you will run out of ammunition. Laser, it has only one consumable, fuel. So that's far more desirable. So everybody is going YOLO on lasers. And again, you don't need that much powerful when it comes to laser. Even few kilowatts generally is more than enough to melt propellers, more than enough to fry any optical sensor. So you can, if you're not kaput it out of the sky, you can definitely blind it. So It's getting money like there is no tomorrow. Just like take money, and people are like, what if we had megawatt class and we can just like zrrr, every brrr. So shut up, take money. Now, this is what we classify as backbone technology, meaning can your country stand on its 2 feet? Depends how many people are there that knows laser, and I mean inside and out, as in like, here's some money, go build me a laser. Can you build it? Not buy it, build it. If the answer is yes, your country can do stuff. If the answer is no, it does not matter. So flat out, it's what we classify as backbone class technology. All this being said, it's a normal thing, it does work, it's here, it's real. But before 2020, and I'm giving an artificial line, but think in that time frame, before that, laser was just something that people were dreaming about. It's like, oh, lasers. After that, things started to fall, as in like the price of laser systems started to nosedive. Things that you can do right now was unimaginable when I was born, basically. So the newest innovation in this market is UV DPSS, ultraviolet diode pumped solid state systems. So why is that? Well, it's 5 watts of ultraviolet. Now, like, wait a minute, is 5 watt, that's it? Like, that does not sound impressive. But be mindful, because again, I talked about the singing frequency, the resonance. It's far more powerful than infrared. If you have 5 watts of infrared and if you have 5 watts of ultraviolet, ultraviolet acts, infrared heats up. So that creates a paradox. Ultraviolet is what we call photochemical reaction, and what is infrared? Thermal reaction. That's why copper is like very robust against fiber lasers, so to say, especially in infrared spectrum. It's like, bro, don't waste your time. Like, you have to put so much power, you're gonna destroy things. So basically, controlled manipulation, yeah, that's not happening. Copper is like, nope. And again, plastics also have the same, so you have to dial it down so precisely, and if you change anything, it's like either it's gonna warp the plastic, melt the plastic, damage the plastic. It's not trustworthy, basically. So ironically, ultraviolet, because it's such a small wavelength, almost immune to all of it. Like, there are very few very specific material that can bounce it back, like aluminum can bounce back certain wavelengths of infrared. So this just acts basically a thing, and you have basically ultraviolet does thing, the end. So copper, glass, wood, like, wait, can't we cut wood with, you can cut it, but you must have seen that charring line. Yeah, in certain woods it can create such a issue, and again, it was a big deal back in the days of CO2 lasers. It would create such a smog issue that it will coat all the gold reflected mirrors and kaput your laser. So ultraviolet does, like, again, you can do things on such a minute way, such a easy way, even with 5 watts of power. That is like, damn. And again, that's the benefit of 355 nanometer beam. Another aspect, this is from a mathematical point of view. Once you have a wavelength that is that small, you can achieve tiny focus spot. It's a physics-based system. You cannot have a tiny spot if your wavelength itself is huge. So having tiny spot means that 5 watts of power is concentrated into much smaller area. So basically, watt per meter square goes bonkers high, meaning almost all of the material just disintegrates because it's so goddamn high energy and so quickly. To give you some numbers on that, you can achieve 20 nanometers of spot size. Now, is that huge or bad? Well, basically, infrared will generally struggle at 50 nanometer, give or take. And again, that's best infrared. So that does matter. It's not like a night and day difference, but if you are etching PCB, it's shut up, take money. So spot size matters. And how expensive is this? Well, it's like a good car, not the most expensive car, but good car. So if I have to talk in dollars, it's like a give or take $10,000, generally below that. And in Indian rupees, it would be 10 lakhs below that. And yes, I'm actually showing you one company that is in Ahmedabad, Gujarat, if I'm not mistaken, 10 watt UV laser marking machine, that is 8,55,000. Now I'm like, okay, why the heck it's so huge? If it's a diode pump, shouldn't it be just a block? It cannot be, because here's the, it's going through transformer stage. So you have pumped laser diodes that delivers the laser energy. Then it goes through NBYVO4 crystal. It converts it into IR. And then you have a doubler crystal, is the first transformer. It goes from IR to green light. Basically, you increase the voltage, decrease the amps. Then it goes to tripling crystal. You basically increase the voltage, decrease the amp. So it goes to UV light, and ta-da, you get ultraviolet photons. So you can see that, like, it has so many steps. Now, like, why? Well, if you do it any other way, you will not get the control and you will not get the amplitude on the output. So just to give you 5 watts of output, it requires a kilowatt of input. So it is very inefficient going through this many transformer, but it does work. And again, 5 watts of ultraviolet is different. So this has made a lot of things that you could not think of, like dealing with glasses and marking glass things and all that, and a lot of other things, specifically with PCB. That's what I'm interested in. It's like, whoa, like this is a thing that you can do. It's not something like, oh, it will require some this and all that. And this sort of machine used to exist. It was just idiotically expensive. It was not even something that you can get a catalog for. Now it's like, yeah, we have it in stock. That's the green point, in stock. Now we come to another aspect that has also fallen in price, kilowatt class laser. Now again, I'm not talking kilowatts. It's not like 3 or 5, 7, 10, 20, it's kilowatt class laser. So fiber laser are very powerful. Now we knew this in 1980, but this was not efficient back in the day. And this was another reason why people were not convinced about lasers viability, simply because yes, you can have factory that is going YOLO on basically laser and doing a lot of quality welding and all that, but nobody would took it seriously simply because the weld cost was high. Why it was high? It was consuming electricity like there was no tomorrow. Nowadays, fiber in principle, and certain defense contractors do claim that they have touched 50% optical to laser output, meaning you have 50 kilowatt going into the laser unit and you are getting almost 25 kilowatts of laser output. That is, whoa, like be mindful, we would be lucky 10 to 20%. 33% now you should be able to buy that, but like 50% is like, damn. Now be mindful, that's just the laser unit. Cooling, depending on where you are, in Alaska, GG, but you're in India, you might be spending some few kilowatts of energy just to cool the damn thing, but you get the point. So it is very powerful and efficient in infrared spectrum. So because it's in infrared spectrum, aluminum does not like it, but because it's efficient, we can YOLO it. As in, now it is possible for you or a household electricity to sustain 1 kilowatt laser output. It will not trip the breaker. We can provide that. And again, if you deal with heating elements, that's like, bro, your room heater is like 1500 watts, as in like 1.5 kilowatt. And that's like a small. So we got this. So that matters. And what does it mean, that 1 kilowatt of energy? Well, it can deal with few of sheet metal. Like, it's like, I got this. You can trust it. It's like, bro, 1 don't worry about it. 2 don't worry about it. 3 ooh, you're pushing it, but it can chew through it. But like basically generally you are below 2 and it's like, I got this. Your computer case, cabinet, electrical system, almost everything is like, bro, we good. We got this. It's good. And so far that's like stuff. But the fact that now we have handheld laser emitters, that changes the game. Basically, we went from laser being on top of a very controlled device like a CNC machine to laser being, ta-da! You can do that. So handheld laser emitters are like actual reality now. So what does it mean? Well, what can you do with it? Well, you can do the same thing we used to do with plasma. Basically, you can weld, you can cut, and that's it. Like for few materials, especially that like 2 or 3 material, you can just like laser cut it, or you can weld it. Now, welding it matters here a lot simply because laser welds have a certain quality to it. That quality is very desirable, specifically if you're dealing with thin metal. Like welding some big medium-sized material, we good. Tungsten, basically, MIG, TIG, and what are a stick. These things were like, bro, we got you. But if it's too thick and if it's too thin, these technologies are like very finicky. Again, there are artisans who are like, bro, I got this, fam. I deal with exhaust manifold, I got this. I can deal with this thin material all day long. But most people are like, no. So laser is one of those points where it's like, I got this. I can go through that thick metal and I can go through the thin metal and shame machine. So it's a big deal. And because that handheld machine is so robust and reliable, you can just chuck it into a CNC. If you remember the early days of like 2015 or 15 to 20, that era, a lot of people were buying plasma machines and they were just putting it on a CNC X and Y coordinate machine and ta-da, you had plasma cutter. So they're like, hey, why can't we do that with laser? Now we do have a dedicated laser cutter, but that's expensive. But what if you have a welder that people buy as a welder, but they can improve its functionality by yanking it into an XY coordinate machine? And that's today. Right now, if you have a bit of money, not too much, not too little, but if you have a bit of money, you can just buy it. And here's the shocking part that is like genuinely scary to people, is that it can do deep penetration welding up to 10 millimeters. Now, what does it deep penetration? Meaning you cut it, you put acid, you scan it, and then you figure out whether it actually welded or not. Yeah, it's laser is so reliable. It has so much wiggle room that if you spend the time tweaking it, even an amateur, like this is the metal, this is how it's supposed to be. You figure out the angle, you figure out the settings, done. Like give it to anyone and it's just like done. That's a shocking thing, because again, that's art in all other welding technology. That like, it takes time. It takes time to build up that kind of skill set and energy. Here it's like, bro, spend some time to figure it out and done. And if you're lucky, you might even have that in preset. So that's a big deal. Like really big. 10 millimeter thick metal handling capacity. It's huge. Like truck metal stones are not that thick. Like that's big. And what sort of money we are talking about? Not that much, $20,000. Now, like, isn't that a lot? Yes and no. $20,000 is a lot of material, but like, for how much efficiency you're gonna get? Because again, TIG machines, welding machines, and all that, those decent ones, they're not free. They're not free. And not to mention, if it takes longer you to do a task, there is a compound interest variable. If you're using a angle grinder cutting material, it takes time. It assumes the energy is very uncomfortable. You have to pay. So, you know, it compounds it. So 20,000 is like, for a business, is like, bro, like if we burn that much in diesel or we spend that much on insurance or all that, it's not that huge. And again, it can also clean rust. Why? Because rust somehow loves that exact infrared spectrum that we use for fiber laser. So you can just put rust out of the material. It's just like laser goes there, rust booms itself, and tada, your metal is clean. Like it will clean material on a like a literal chemical level. Is like done. So that's like how much money you are willing to pay for a device that can do all three things. Basically, cut the material, clean the material, you know, weld the material, and all of it is like, you know, clean, like clean grade. So it's like, it's becoming a thing. Let that be very clear. It's not like it will change the world, but the fact that it is so good with so little money and so close to so many people, it's like, whew. It's like 3D printer, like how big of a deal Ender 3 was. It's something like that. So what can we expect in the future? Well, reality is from 2026, laser have gone freehand. Basically, you will see that in upcoming months that people are like, hey, we have a laser, ring. So instead of robots or a CNC bed, we are the one who's yielding laser. That has implications. And from a money point of view, it's a very little business expense. Like it's not like you know, end of the world. Like it is a decent chunk of change, but it's like, yeah, it's a car, like it's a truck, business stuff. It's not like, you know, millions of dollars, which it used to be only a few years ago. Decades ago, you could not even bought it even if you had the money. So that was the whole point. And what does it mean? This sort of money, solo to small team can do it now. Meaning, if you have a decent sort of business, you can just like do it. And if you have a small team, it makes sense to do it. And you can do things that factories were required to just try in 90s. As in, like, there are people who are just like, you know, reaching their 35th birthday and they're like, bro, when I was a kid, we were seeing these things in TV where they were showing like, you have Toyota factory that has laser welding. Now I can just like eat. That's a reality. So it's a very big, what you call, paradigm shift. And making welding from art to a task, while it does have a penalty that welders will not get paid that much, but it does have a improvement where it's like, it's a done thing. It's like, it's a sorted, like we don't worry about it. We got this. So it does improve productivity if done correctly. So that is there. Basically, you are taking sheet metal industry from industry to garage. And you're like, is sheet metal important? Everything around you generally has sheet metal. Be it your car body, be it your stabilizer, be it your washing machine, dishwasher, anything and everything is sheet metal. So having experience over proper sheet metal, you good. You got this. And again, my personal favorite, using UV for PCB. And again, I deal with PCBs, I am aware of it. It takes time. Even if you're like, okay, but I can get it from China. It's still 1 week. Ask a company what is the value of 1 week of waiting time versus, you know, just, hey, go to this lab, be done in 2 hours. Short uptake money. Tell that, like, hey, you can, you know, experiment with your board right now. Basically, you come to your office and you have a CAD design, dump it into laser, get it etched, then put a UV cure resin and cure it, have that mask. Tada, you have a PCB that is ready for surface mount devices, and you can even drill into them, and tada, that's just like ready, take it and go. What is the value of that? Short uptake money. What's the value of a metal fab shop that is like, bro, we can deal with thin metals, we can deal with many sheet metals, we can cut and we can create a tab and joints to actually give you a robust structure that people are like, damn, this is some good stuff. Shut up, take money. Shut up, take money. So this is amazing future. Like, this democratization of this technology is enduring. So this was a presentation on basically the big impact the cheap laser is gonna have in next few years. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.